All right, this is another fast one that is relatively straightforward. We're going to deal with special right triangles. Special right triangles, we have a 45, 45, 90 triangle, and then we have the 30, 60, 90 triangle. And so when we're talking about the 45, 45, 90, we have the sides that are always going to be congruent. The legs will be congruent, and the hypotenuse is always going to be the side times rad 2. When we talk about 30, 60, 90, the 30-degree angle is opposite the short leg. The 60-degree angle is opposite the long leg. They do call it the short leg and the long leg, and then the hypotenuse. So the short leg is A, the long leg is A rad 3, and then the hypotenuse will be twice the shorter leg. So nice and easy. So when we find out that E equals 9, so E is the long leg. So they start you off with a pretty complex one. So if the long leg is equal to A rad 3, so 9, that's a horrible 9. We can say that 9 equals A rad 3, and we're solving for A. So we want to find the short leg. This is A, this is a long leg, this is a hypotenuse. So we have to find that short leg. So we'll divide by rad 3, divide by rad 3. Now you can't have a 9 rad 3, you can't have a rad in the denominator, so we have to do what we call rationalizing. That gets rid of the radical in the denominator, multiply it by its own rad. What gets rid of a rad 3 is another rad 3. So that's the logic behind multiplying by rad 3. Has to be a value of 1, because we don't want to change its value. We want it to be equivalent, so we have to multiply by a value of 1. And now we can simplify this to 3 rad 3. So F is going to equal 3 rad 3. And then my hypotenuse is going to be twice that. So that's going to be times 2, which equals 6 rad 3, because you're just multiplying that by 2. You only multiply the outside with the outside, inside with the inside. So they start you off with a pretty good one. D, which is a hypotenuse, equals 2 pi. So we know that the short leg is going to be half of that. So F equals pi, because 2a, we could set it up again. If this is the hypotenuse, and the hypotenuse is 2a, divide by 2, divide by 2, pi equals a. And if a is pi, then this is going to be pi rad 3, because we multiply it by the short leg times rad 3. Still 30, 60, 90. F equals 1.2, so the short leg equals 1.2. Finding the hypotenuse is going to be easy, 2.4. And then this is going to be 1.2 rad 3. So I don't know if they want you to convert that to round it to a decimal number and multiply it, but I would just write 1.2 rad 3. That would suffice in my book. Now we're dealing with 45, 45, 90. So X, my side, is going to be rad 3. So this is going to be rad 3 because the legs will always be equal. This is an isosceles triangle. Angles are the same, so the sides are going to be the same. And then my hypotenuse is going to be rad 3 times rad 2, which equals rad 6. Rad 6 cannot be simplified, and we leave it like that. Now it tells you y equals pi. So x is going to equal pi, and z is going to equal pi rad 2. These are nice and easy. Now they tell you that the hypotenuse is 12. So our hypotenuse, my hypotenuse equals a rad 2. We'll divide by rad 2, divide by rad 2. Again, we can't have rad 2 in the denominator, so we're going to rationalize it. What's going to get rid of a rad 2 is another rad 2. So 12 rad 2 over 2, which simplifies to 6 rad 2. So each of the side lengths is 6 rad 2. That's it. That's how hard it gets. That's not really that complicated, as long as you know the trick of setting it equal to and also remembering to rationalize your radicals with, or your fractions with radicals in the denominator.